well, thanks everybody for coming out. We're going to record this, obviously, and everything gets posted to the Lancaster AI site so people can watch it later on and participate. And so what we're going to discuss today is Python. So we sent out a survey this past fall, and somebody may have filled it out, where we asked what are some of the topics that people want and how would they participate. And so Python was one of the top listed things that people wanted to learn about. So today I wanted to kind of talk about what are some of the most common things that you do in Python, and maybe how that looks, and maybe what some of those solutions are. And I'm not going to go, again, too far in depth into any one of these. We are going to start putting together some paid courses, I think, for people to be able to take, specifically targeting Python and, let's see what else, maybe PyTorch, something similar like that. But we're going to take a look at these, and the most common thing that we do is we take data and we reshape data. And I know that it doesn't sound very cool and very sexy, but really this is on all my last paid gigs that I've had over the last 12 months, over my own work that I've done with the Suji 1 AI stuff. Almost everything has been reshaping data. All right. So what we're going to do is we're going to take a look at a couple. I'm going to look at Python. We're going to take a quick look at some OpenCV stuff, and we're going to look at Pandas, and we're going to look at a PyTorch example. Okay. So what we're going to do is let's start here with just something simple with Python. And I'm not sure how familiar people are with Python. One of the challenges that you have in reshaping data is often you'll have a list of different pieces of information. So I have a list. Python treats strings as a list, so you can easily separate these out. And so you could easily be able to go through and apply different information to a list. But the question is, how would you do that? Now, in many ways, you can use what we call lambda. Okay, and I'm not sure if you're familiar with lambda functions. No, I got 2 heads, yes, 2 heads, no. Okay. Well, lambda functions essentially allow you to call or it is known as an anonymous function. And you're able to pass it. It'll get a single parameter and it'll do something with that parameter, okay, on a list. So, however, one of the challenges I find in Python lambda functions, you also have similar things in other languages as well, like JavaScript, is that sometimes it can be unreadable. And that's the main challenge that you have. So one of the nice things about Python is that it's very user-friendly. And you definitely want to have something user-friendly. So let's take a look at this. So we're taking a look at the letters here. This is Jupyter Notebook, in case you're not familiar with it. I assume you are probably. But this allows you to go stepwise through Python code and run things. So we're going to create an empty array, or that's JavaScript, empty list, okay, an empty list, and then for a quick for loop. So what this does is, because this string is a string in Python, we can iterate through it. So every iteration, so every item, in this case every letter, for every, we call it a letter, so we set, essentially what we're doing here is we're going through and separating the H, U, M, A, and N. So we're going through letter by letter. So we go through, we get this H, assign it to letter, and then to this array, we append the letter. It's a pretty standard way of handling a list. And then we just print it here. And this is what our list is, H-U-M-A-N. Okay? So that's a for loop. Pretty standard stuff in Python, a for loop. However, you can create a list comprehension which reduces the size of your code and makes it still legible. Okay? So here, notice that we have our declaration of what we want. We want a list, so we have H letters here. And then we put it into an array, right? So we know what the return type is. And then we go in here and we go letter for letter and human. So what this means is we go through, I get the value for the letter, and And what we do is we just display that letter, right? It just calls letter, right? So it calls that actual item. Okay. So that's a list comprehension. It gives you the same exact value, HUMAN. Okay, so how would this work? So I'll give you 2 more examples that might make this more clear. So the number list, it will go through x for x in range 20 if blah, blah, blah. So what this does is it goes through, creates a list of all the even numbers from 0 to 20. Okay, in a range of 20, so that's, right? So we go through each item, each number, 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. And if it's modulus 2, so if you can divide it by 2 and there's no remainder, then we just display that x. Okay? And that's all this is. So we just return that x. Return that x. Okay? 0, 2, 4, 6, 8, 10. So let me show you an example that might make it a little bit more clear. And so this is where we do the same, something similar, except we pull it out into a function, and we call that function. Okay? So here we're just returning x, whatever this, returning the value, right? But here we're actually taking the value and doing something to it. So it allows you to go through every item in a list and apply some function to it. Every value in a list, you do something to it and update it, and it updates the function as you go. Okay? So for every x in range 20, we run this function, changes, and we pass in the number for the x. So x in here, okay, is that number, and then again we run the same if x modulus 2 equals 0. This is essentially what we're doing here, and it prints out a list. Instead of, I can probably run this. If x equals 2, return x. You get it, x is 0, none. All right, so it's going through every single number.
Or in that case, you can have an else if it's prime, return something else, return 0. It's not a prime and not divisible.
Let's see here. Let's see. So what it's doing here is getting every single value. I would have to add the if x to determine what numbers it actually runs it on. So if I wanted to do that there again, this should work. Now code 1. There you go. So I put the conditional up here. I took that conditional off. Okay. So it runs that function. So I mean, essentially, list comprehension is it's just a way to go through and do something to every item in the list and create that. And it's a great way to quickly generate lists and quickly store data, take data and reshape it. Because that's constantly what you're doing. You're constantly getting data and you're constantly reshaping it into something. And this is just a quick Python thing. I just wanted to show this quick Python thing. And then, yeah, so let's just move on to an OpenCV thing. Okay, so how many people here have used OpenCV? Okay, so OpenCV is computer vision. Okay, so this is where you're taking different kinds of information from either your webcam or the system. You're bringing it into the program and then manipulating it somehow. OpenCV is the top program for computer vision manipulation, and it's free, and it's pretty powerful. It has compilations with CUDA, and you do a lot of stuff with it. So now we use the Python version. It's originally written in C++. It does have a Python version you can use, and if you want super speed, you can use the C++ version. The Python version is pretty close. Like, it uses this wrapper called Cython, I believe, to call a lot of the C stuff. So there isn't much loss in speed. But let's talk a little bit about this. So I do this, like, if you're using a Raspberry Pi and you want to be able to float it into a neural network, you know, take it into a thing. Let's take a look at this. So here I'm just going to run this program. So let me open this, make sure I am in. I gotta change my virtual environment here just to make sure. Oh, shoot. Okay. All right, let's see if this runs real quick. Oh, So this one's supposed to run off the webcam, and I just have it drawing a random rectangle on the screen. Okay, it's not dynamic, but I just put it in there. We're going to take a look at the code in a second, but it's coming straight off of my webcam right here. Okay, and we'll take a look at what this other code is saying. So what we're doing here is these are just parameters that I'm keeping for now. X and Y is where and right and bottom and thickness. These all are dimensions of that rectangle. So when you're dealing with AI stuff and computer vision stuff, this is all going to be dynamic and chosen by your application. So for instance, if you're doing object detection, right, this is all dynamically generated. But I just used fixed variables for now to make all the math work. So you set up, what you have is this video capture process in OpenCV, right? You instantiate the program, you have a video capture, you tell it on what, I think it's the UVC port, I believe it's called, maybe not. But it's the specific port where the video cam is almost always 0. So that's your 0. So what you do is that's their capture. And then what you need to do is you need to actually read from that capture. Okay, so the capture is just kind of like buffer that's running constantly. And then you run the read, which goes in, pulls out a frame, and pulls it into a variable for you to be able to access. And so it has two things here, and in Python, you can return, this is called a tuple. If you're familiar with Python, you can return more than one variable at a time. And so here, this cap, when you read it, it returns, see, it'll tell you, well, you can go through and read all that. I can't read it from this side here, it's tough. So it's the return value of the image is what it returns here, right? So that's what is in the documentation. Return value and the image. So here, we just assign that return value to return, which we just throw away, we don't even use. But we got to assign it to something. And then we have image. Often you'll see this used, you'll see this, right? You'll see an underscore. That's often what you'll see in Python. So it's just you're just assigning it to some character that you're going to throw away. But you get the image, and you read it. And then I just wanted to show you that here we're using some resizing. And here I'm going to use CV2 resize. So when this image comes in, it's coming in around, I think this is a 1280 by 720 cam, might be a full HD cam. So it's coming in very large. And so if you want to resize images, which is always what you're doing when you're doing AI stuff. So if you're doing image classification, you're doing object detection, you're doing some kind of image resize to get it to match a larger data set. So I used 416 by 416, which is one of the standards for the YOLO object detection system. Okay, and they train that on Cocoa and VOC, Microsoft Cocoa and VOC system, and those have specific sizes that they get resized to. So here, I'm just resizing this image to a 416 by 416 image, okay, and using an interpolation. And then what I'm doing here is I'm using this time.time and time.time and then printing it so that you can see approximately how much time it takes. Now, this isn't the best profiler, okay? This is a really rough, dirty profiler. If you really want to get a profiler of how fast your system is running, you can use something like cProfile. There's also plenty of other open source libraries that you can use to see how much each line of code that you're writing is taking to process, okay? And I recommend it. Now, I did this here because I wanted you to see that there is a difference between these two. And so when you resize an image in OpenCV, which you do often, you lose time, okay? And it doesn't seem like a lot, but the milliseconds add up, okay? So we'll take a look at that. So let's just keep going through. And then here I draw the rectangle. That's all this is drawing a rectangle. This is how you do that. CV2 rectangle, and you pass in the information, color, and the thickness. And then this right here is the IM show, which means you're showing the frame display, which is that, where we saw my image with the little rectangle on it, okay? Now, IM show also takes time. So you only use that when you're debugging, right? You don't want to use that on your actual application, but you keep the code there because you're always going to be debugging. So it's a good way to know that yes, you may lose a little bit of time there, but it still is something to have. And then just did, a speed per frame. And then from the speed per frame, you can calculate approximate frames per second. Okay. So in this particular one, you see speed of drawing a rectangle is 1.93 to e to the negative 0.5. So we're talking about less than a millisecond. Less than a millisecond to draw a rectangle. Not bad. Okay, that's pretty fast. You're not going to lose a lot of speed by drawing rectangles on your object detection system. But the resize, okay, is starting to add up. So I'm just going to show this. It's 0.0013 seconds to resize an image using the interpolation of inter-area, right? Because you remember, when you resize an image, what you're doing is you're making a bigger image, and then through each pixel, the OpenCV has to go through using what's called a kernel, so like 9 squares in a circle, like a 3x3 grid, and it has to like maybe average them or like come up with some kind of information to populate those empty zeros, right? That's what it's interpolating. So it's calculating that. It has to go through all the image and calculate that stuff. So that's why a resize takes a lot of effort, because the computer's got to do a lot of work. Now I know 0.001 doesn't seem like a lot of time to us, but to a computer that does billions of calculations per second, that's a lot. That is a lot, So that's just something to keep in mind there. So let's take a look at what we did if we just change it to a straight resize. So 0.0013, right? So let's close that one. Okay, and we'll run this again. Come on, close. All right, so speed of the resize. Now, when we don't use this specific type of interpolation, we just use the default kind of interpolation, which you can look up in the documents what that is. I forget off the top of my head. It's not inter-area. There's a different kind of interpolation that you use by default. Okay, but there are reasons that you use inter-area because it's more accurate. Do you want speed or accuracy? These are your trade-offs that you're always looking at. And so the speed of the resize here is 0.0006. Remember, the other one was 0013. So we're talking about a 50% difference in speed just by choosing which interpolator we want to use in OpenCV.
I forgot to pay attention or write down. What was the speed of the drawing the rectangle on the previous iteration?
It was 1 point something to the e to the negative 5.
I thought so. Now it's going to 2. It's double?
It's a little bit faster, or a little bit slower. Yep. On this particular one. I'm not sure why. I don't have an answer for that.
Okay. So okay.
All right. So that's video. Now, here's one of the things I want you to see here. So, what do you think is the slowest part of the system? What's the slowest part of this process? Any ideas? Well, how about we look at an example? I want you to think about it. I'm going to close this one off.
Are you thinking of running a while loop?
Yeah.
As far as factorization or something?
So we'll see over here real quick. So the speed of drawing the rectangle, speed per frame. So each time it goes through there, it takes 0.06 seconds. Right? Now here, let's just do this one. So this one, we are using a static image, right? And we're going to save it to sample.jpg. So we're not even going to show it, we're just going to save it. Okay? Sample.jpg. All right? So if we do that, save it, clear this out. Okay. So difference of 0.06 versus 0.008. So we're talking about 5 times. Roughly. I mean, this is just a guess. These aren't exact. Okay, this isn't CPU cycles. This is, internal time indicators.
It's changed 2 things: the video capture and the display.
Yep. So it's I/O.
You said 5 times, isn't it just closer to an order of magnitude?
0.008 versus 0.06.
0.06.
Yeah, so what is that? Oh, yeah, okay, yeah. It's the I/O is the answer, is always the problem. And it's always the bottleneck when you're doing any kind of video cam. That's why when you're doing these kind of things, NVIDIA recently has been moving to things that are more like Apache Spark, I believe, where everything's kept in memory for as long as possible. You never touch the disk, and you're really trying to bypass as much, how do I put this, much software reading as possible. Like you want to do as much in the hardware as possible, okay? So if you can get all this information to a piece of hardware, read that image directly into some kind of variable at a low level using C or Rust or something like that, you could get way faster speeds. This is how we're trying to overcome this issue of speed. Because if you shave off the amount of time it takes for your I/O, you can do more with your neural networks, right? Because those neural network seconds are precious. All right. So that's just a little bit about OpenCV. So I'm gonna, just so you know, I'm gonna post. This is already posted online at the GitHub API. I'll post it up at Lancaster AI. You can use these. I mean, they're free. Do whatever you want with them. Like if you want to play around your Raspberry Pi and play with a camera and just throw this script in and play around with it and use it and see how it develops and do your things with it, you're more than welcome to.
So this one's the one doing a static image?
This one's doing static, and this one up here where you have the while loop is constantly pulling from the I/O or the.
So if you change your frequency of scanning, then you should, then that's going to cut out the amount of I/O that's going on. So is there a compromise there? Because each frame is a static image.
Yeah.
Do you understand? Am I explaining myself?
No. So what are you suggesting you would do?
Well, I'm asking if there's a compromise between scanning.
It always pulls as fast as it can.
Right. Okay. Yeah. As opposed to a static, so somewhere in between is not to pull as fast as you can. Reduce the frame capture rate, if I've got the terminology correct.
Yes. Yes.
So that would be the compromise somewhere between quality and quantity.
No, it doesn't matter.
Okay.
Like you're always going to be able to pull. Generally, you're always going to be able to pull at 30 frames a second. Like that, most machines can pull at 30 frames a second, which is real time now. Even the Raspberry Pis can.
Well, but if and maybe I'm misunderstanding. That's why I'm asking. When you were pulling as fast as you could, I thought the I/O time was increasing, which was taking time away from the processor.
Yeah. It takes. Yeah.
So let me try again.
Okay.
If it's pulling right now, if it's 30 frames a second, if you decide to pull it at
60 frames or 15.
The other way.
So
less frames per second.
Yeah. 15.
So that should reduce your I/O time.
Yes, that would be, yes. Yes.
So
you can pull at less frames.
So I'm saying that would be a compromise between one end that's sucking up.
Yeah, if you wanted to.
Okay.
Yeah, so if you wanted to run larger neural networks, and that's often what happens, you'll reduce your frame rate to be able to do that.
Okay.
Yep, absolutely.
Okay, thank you.
Mm-hmm.
And for your patience for understanding.
Yeah, no, that's a good one.
Yeah, just a quick question.
Yeah.
The original was a dynamic based upon the camera, correct? Am I missing that?
The original.
The original frame that we measured, the first one,
Yep.
was right off the camera,
Yep.
dynamically.
Yep.
This was just a static,
It just, yeah.
something different.
It's a little bit different, yeah.
Yeah, I mean, as far as totally the actual photograph was one captured of all the pixels there, but it was static. Yeah,
Yes.
It's gonna be.
It's gonna be a little bit different, yes.
Yeah. No, what I meant is, well, okay, I think faster. So, and a side note, it's different but similar.
Mm-hmm.
Just recently, maybe in the last couple months,
Mm-hmm.
there's a new product out. It's a drive. It's actually a drive. It's actually a neural network on a stick. I think Microsoft came out with it.
It could be the neural compute. Is that the Intel one or the video?
What it is, it's using the autonomous for some
Yeah.
vision autonomous vehicle because of the nature of just that to get the latency of they need much quicker things so they can quickly get it in there, store it, so to speak, but have it available in the main neural network for
Yeah, they're doing
it's like $70.
yeah, the neural compute stick. I think is people are plugging it into the Raspberry Pi and using that.
Yeah.
If you download it and she download it, you'd be able to sit at the table if you want to sit at the table. It wasn't paying attention.
All right, so let's move on. That was just an example of OpenCV and the things that I do constantly on computer vision. I don't deal a lot with OpenCV because I moved on to other problems, but a foundation in OpenCV is really crucial if you're ever going to handle any kind of computer vision. So Pandas, okay. Pandas is lots of fun, right? So who here has used Pandas? Okay, so we got 2 Pandas. Okay, great. So then this is probably going to be old hat to you. This is just the things that I most commonly do in Pandas. And I've gotten jobs where this is generally a lot of what I do. And so you get paid to take this kind of data and just figure out simple computational stuff. And so I just wanted to show some of the most common things that I'm doing over and over again. Now, usually I've extracted this stuff into my own functions and own mini libraries, but you'll run into this a lot. So Pandas is just a way to handle data frames, and think of it as Microsoft Excel. It's essentially how I think about it. Okay, so let's just import these in the right virtual environment, I believe. And so what we have is we have this data frame. I always prepend it with df, so I know I'm dealing with a data frame. I just call this raw, and we're going to read from the Excel file from our path, which is just the sample XLS file. Let's see. And this is what the file actually looks like. Just a big Excel file with a ton of dates in them. Now these are strings, and these are just random integers between 0 and 10,000 that I threw in there. Okay, so it's just random data, okay, with some date times in them. Now, these are not actual date times. Date time is a content type. What I mean by that is, like a string, integer. Date time is its own content type in Pandas. So here, first thing I'm going to do is you always look at your data. You want to make sure that your inputs are right. Here we go. Boom. Oh, hey, I got a date. So I got my total 1, total 2. Awesome. Boom. Okay. So the first thing that in this example, I want to create 2 data frames. One using the date time, and we're going to compare them and graph them both in one graph using Matplotlib. So I just want to show you what that looks like. So a lot of it is getting data, moving it into special graphs, manipulating that data, graphing it, and doing, you can do some sample statistical analysis like mean, median, those kind of things. Or you can do further on, which I won't cover today, is when you get into the more exciting stuff like linear regressions and stuff along those lines. So, but right now, what we do is I'm just grabbing the date and total 1 from this data frame, and I'm assigning it to a completely new data frame. Likewise, doing the same thing for this one. So I'm creating 2 new data frames here using date and total 1 or date versus total 2. Now, the other thing I'm going to do is I'm going to convert them from a string to a date time. And you'll understand this becomes important later on. And I'll show you why, but let's just do it first. Okay. Yes, I know it's probably not the best thing to do. All right. So there are other ways to do this. It's not deprecated yet. They want you to use the row indexer and the column indexer equals value. So there is a new way that's come out recently in Pandas to be able to do that. The old way still works perfectly fine. Okay. And then I just want to look at the first sample head here. Okay, so this was sample 1, which I created up here. So now it just has a date and a total 1. And so let's calculate this using Matplotlib. So what we're going to do is we're going to create a figure. So Matplotlib has its own figure. We're going to create our axes, and then we're going to plot. This is x. This is y. This is the color and label, right? This is the label for our key. creating a table. And then our legend, we're just gonna give it a font size, we're gonna add some labels, add a title, the awesome meter, right? Level of awesomeness per day. Okay.
Do you want to change the label?
Which one?
The second one, should that be say 2?
Sure. There we go. And then we're just showing it. Now you can either save it or show it. You can't do both at the same time. Depends on what your client needs. But so for here, okay. So what do we get? Crap. Okay. Well, that's not very useful. So often what you're doing is you're just graphing out and you're just looking at data and exploring data and just like looking for relationships, thinking about different things, making a couple of guesses. This is just a random one, a random guess. Like you would look into your data and you'd probably make some more educated guesses about things that you want to take a look at, different trends, different things you want to uncover. But this is, I would look at this graph and I'd be like, what the heck is going on? Well, there's too many data points, right? And so you can't really get the kind of information we're looking at here. So the next thing I would do is like, okay, how could I group things together to make a more efficient graph? Well, you can do a histogram. Histograms, you have bins and groupings. Here, though, I'm going to what I'm going to do is I'm going to set the date as an index. But what I'm going to do is I'm going to sum all the values by per index. So what I did is I go through the sample, right, which is the data frame. I group it. All the data frames get grouped by date, so there's one date, right? And so it has a list of all these dates. It creates like a temporary little area where you have a list of the dates. And then I'm going to sum the totals that are in that and apply it to each of those dates. And so what that gives me, if you look here, is this guy here. So it gives me the dates with the total awesomeness for that date. Right, so it's not so spread out. And then we go through and graph our stuff together. See, I got it here. I got it right here. I just missed it on the top. And then you do your awesome meter, awesomeness per day. All right, and you have a little bit more information now. It doesn't look entirely random. I probably should have reseeded. So that'd be my guess about what happened here is that the seed was used the same seed for this for quote unquote randomness.
As an aside, that image reminds me of something you'd see inside a cave that was made 10,000 years ago, which makes me wonder if they're more advanced than we thought.
Yeah, maybe they're doing some major calculations there.
Good on that.
So, but if I was to look at this data, the first thing that would really appear to me is, okay, well, awesomeness definitely failed at the end there. What's going on? My first thing is, okay, is there missing data? Like that's always the first thing I look at. Like, and often there is. Maybe we don't have enough data points, or maybe there could be any number of reasons for it. It's not. There's never a simple explanation. Sometimes there is, but more often than not, it's you got to dig into maybe why the client doesn't have information. Maybe there was a storm. Like, what if you're working with a storm cleanup kind of company? What if there was a storm that came through and that threw their numbers way off, right? And you might look at when you're doing like linear regression or you're looking at graphing stuff out and showcasing some information for their dashboards, they'll look at the spike and they might try to extrapolate conclusions that aren't true. And so this is only the first step in that process of taking a look. But you should really be able to go into Pandas and using these kind of tools. These are just simple tools to recalculate different things, move things around and graph them. There is a ton of tools for Pandas out there. You can do any kind of searches for different things you want to do. You should be able to find them fairly straightforward. Okay, but this is one of the most common things that I'm doing when I get data sets. First things, exploring the kind of data. All right. So let's go through and look at PyTorch. So who here has worked with PyTorch? Okay, 2 people with PyTorch. Okay. So, all right. So what I'm going to do here, this is from an open source repo that I put up there, which is PyTorch YOLO v3. So I used a gentleman's instructions on Medium. and went through and kind of updated it a little bit for PyTorch and documented every line of code so that I knew exactly what was going on at every piece. And it took a while because you got to know how things come back, et cetera, et cetera. So I'm going to take a look at the first one. So the first thing I'm going to show you is this. It's called predict transform. So this is just predicting, making a prediction on bounding boxes is really what this function is doing. The first thing I want to note about here is the fact that I use the documentation and how critical it is to document stuff. There is new kind of type scripting available for Python. It's fairly recent. People have started using it. But I still use documentation constantly, and it's not for anybody else. Like, yes, if you're on with a bunch of other programmers, you're going to want to use this. But I use it for myself all the time because I'm never going to remember half this stuff as I go through. I mean, I put together almost 100,000 lines of code for recent the Suji 1 stuff that I was talking about earlier. Most of it in Python, and I wrote things like 18 months ago that I have no idea what they do if I didn't have documentation. It's just so necessary. And so here's a general thing that you do is you write down a description of what it does. You write down what the parameters are and kind of what those types are, if you can, and then what it returns. All right, so if I look here, notice that when I hover over it then using an IDE, all that information appears right there. Okay? And so it enables you to go through and understand this. Another thing is that I recommend, when you can, to use default values. Python allows you to set default values when you pass parameters. It's a good habit to have a default value of some kind in there. You don't necessarily have to have it if you're going to use other kinds of fault correction in your program, but it's definitely helpful in a lot of cases. So this particular one, I'm just using this to describe the actual function, takes a detection layer feature map and turns it into a 2D tensor where every row is a list with objectness, bounding box coordinates, and class probabilities for each anchor. So essentially what it's returning, what it's receiving, right, is a grid. Okay, so the prediction, it's receiving a torch tensor, right? A tensor is, essentially it's a list, but it's a special kind of list. All right, and that tensor is shape of 1 by 255 by 13 by 13. Okay, so what is this? So I can't go into teaching everything about YOLO here, okay? That's beyond the scope of what we're talking about here. But essentially, this 13 by 13 is the grid that YOLO divides the image up into. It divides it up into a 13 by 13 image. Okay, this is the first layer of detection. It has 3 layers: 13 by 13, 26, and 52. Okay, and so, but this one is the first one, the 13 by 13, and 255 represents the class probabilities. Okay, and the bounding boxes here. So what you end up having is you have, or anchor boxes, sorry, it's not anchor, it's, no, times the anchor boxes. So it's class probabilities with the bounding box times the anchors. Okay, so I won't discuss anchors. There's 3 anchors for each piece here. And with Cocoa, there's 80 classes, and then there's a bounding box has 4 coordinates and 1 for a background. So it's it's 4 plus 1. It's always what it is. I don't expect, I mean, nobody remembers these things really, but that's what the shape is. That's what it's coming in as, okay? That's what the detection layer comes in as, a shape. And so what we have to do is we have to get it into this shape here, which is a 1, which represents the batch size, right? These are the batch sizes. And then by the grid, right? So we have the number of anchors in the grid. So what we have is a 13 by 13 grid, and there's 3 anchors in each grid that get detections on them. So that turns into 507. It's 13 times 13 is 169, and there's 3 anchors. 169 times 3 is 507. And then 85, right, is this number. So essentially we're just rearranging the information, right? So here's the grids, and here's the class sizes with the bounding boxes, and the anchors are tied into here, and we're spreading it out into a different shape so that we can do different things with the data, right? That's what we need to do. We're constantly reshaping data, moving data around, reshaping it so we do other things, okay? So, and then we get the input image dimensions, the list of the anchors, number of classes, etc. So here I'm going to list these out so you can see them. All right, forget the function. We're just going to look at the actual information. Actually, let me run this to make sure. Let's change our virtual environment to. Oh, if you're not using virtual environments, you're doing it wrong. Some people use Conda. By all means, use Conda. No problems there. It's awesome. Okay, here's the PyTorch one. All right, so that should work. Let's make sure that Torch is in there. I'm still using it for the kernel up here. 1 second here. Switching to kernel. There we go. Okay. All right. So I'm gonna just duplicate these. So I create a new tensor, an empty tensor using PyTorch, and then I just populate it with ones, just to have some values in there. Make sure it's this shape, the 1, 2, 55, 13 by 13. Input dimensions, 416. These are the anchors. These are the size of the anchors at this shape, and the number of classes. And then I just print the prediction size so I know what it is. Right, it's working. Okay. So, these are a number of pieces that we do so we can use the data for later. And so often one of the things that you have when you're building these neural networks is you have information stored in these shapes, right? And often they're multiplied together. So like grid size by the number of anchors, you know, because you have to have 3 anchors in every anchor box. So if you have a 13 by 13 grid, there's 3 anchors in each one of those boxes, right? So how do you represent that? Well, you put that information in a 13 by 13 by 3 grid, which is 507 dimensions. Okay, so that's 13 by 13 by 3, 507 values. So we need to get, those are the kind of things that we need to figure out. We need to pull that information out. I won't go into it too much, but these are essentially the values that we get, right? You kind of have to figure these out. This tells me my back size, the stride. So, okay, so we talked, you remember stride in neural networks? Stride is how far you go across as you're going, how many pixels you go as you're moving through the image in a convolution. So here, the stride is 32, which is enormous. So that should give you, if you're going across 13 by 13 grid, stride of 32. And that gives you this grid size here. Bounding box attributes, again, 80 classes, 4 plus 1, number of anchors, and then here's what the actual anchor values are that are resized for that grid. Okay, so what we need to do is we need to get this prediction map data down to a 2-dimensional tensor. So if I had to convert this 1 by 255 by 13 by 13 into, you know, this puppy here, which is a 1 by 507 by 85, I gotta start moving numbers around. I gotta figure out, okay, how do I do this? So I know the 507, right, is, okay, that is the grid. It needs to be broken down to 169. So I need to get a 169. So one of the things that I can do is I can say, okay, well, let's fix the size of this so that I use prediction.view. This is one of the PyTorch tools to reshape it. And so what I'm going to do is I'm going to change this into, we're going to keep it by 1. We're going to leave the bbox attributes by the number of anchors, right, as 255. And then we're going to combine this as grid size to grid size. So now this comes down to 1 by 255 by 169. So I reshaped it using this torch.view. Right? This is a torch tensor, just use view on it. Okay?
So the view means it's not actually perform that calculation until assignment, or?
Well, no, it is assigning it here. Yep.
I didn't know if there was any thought of like method chaining.
Yes, you can definitely chain these methods. Absolutely. In fact, down here I show how not to chain it, specifically because I want it to be readable. But you could definitely chain it. In fact, that's what a lot of people do. Right. So, okay, so that's great. So then it's 1255 by 169. And then I need to get it over 1, right? Because I need to get that 507 in here, right? So it needs to be 1 by 507. So I can kind of move this over. So one of the things that you could do is something called transposing. And then so I just use 1 and 2, and I turn it into a contiguous tensor. And all this does is generates a tensor and rotates it to 1 by 269 by 255. So it returns this here. And then here is where I create the final tensor, okay? So it is, prediction view is the batch size, which is the grid size by the number of anchors, and then the B-box attributes, 1507 by 85. And so what I do is I take this prediction tensor, which has a bunch of data that comes in, reshape it through this whole process, carrying the data through the whole process until it's a 1507 by 85 setup. And if I was training, I would just return this prediction. Now, when you're inferencing, which is doing essentially you're running the model in production or whatever, there's other things to do. You're not done. But for training purposes, we just done a prediction, and then what we'll do is that'll get sent back to the training program, which will then calculate loss, because it'll take that value versus the ground truth value, calculate the difference, and then run back propagation and that whole process. And so that's kind of how this whole works. Now, one of the things that I do a lot as well with reshaping is I'm just going to show you squeeze and unsqueeze real quick, because sometimes you just need to add an extra dimension to make it work, you know. And so what if you wanted to shrink the 1 by 507 by 85, you know, to a torch of 507 by 85? So for instance, you know, maybe you just wanted to be able to operate more quickly on, I don't know, throwing it into a Pandas. You know, if you're using NLP, sometimes you'll take this and you'll throw it into a Pandas data frame so that you can run something on it. It happens all the time with NLP to be able to use embeddings, right, using Pandas as well. So if you wanted to do that, you would do something called squeeze. So if you think of squeezing your tensor, you just pop off one of the dimensions. So you talk about which index. So here, this is 0, 1, 2. So if I squeeze 0, I squeeze the 1, and guess what? It turns into a 507 by 85 array. Or tensor, sorry. And likewise here, if I wanted to unsqueeze it, if I wanted to turn it back into something that then I could dump back into the neural network, well then I just unsqueeze it at the 0 index, and guess what? It's a 1 by 507 by 85. Squeezing, unsqueezing, reshaping with view, moving things around, all the time, what you're doing with PyTorch. And again, this is, you can see a full example here at this address. If you want to check out the YOLO v3 and actually follow it line by line about how PyTorch is, but there's tons of PyTorch stuff out there. I highly recommend PyTorch. I know a lot of people really like TensorFlow, and TensorFlow is great for a lot of things. A lot of people are switching to PyTorch, mainly because you can create stuff very quickly and easily. And there's a lot of work out there, and it's getting to the point now where a lot of the PyTorch models that you use can actually be used in production as well. So not only are they being used by a lot of researchers to prototype stuff very quickly, but they're also being used in production now also as well. So there's a lot of power in there.
Can you unsqueeze something that hasn't been squeezed?
Yeah, of course. Yep, absolutely. Absolutely. These are just tools to reshape tensors. That's all they're doing. All right, so you know what? I missed something in the Pandas stuff, didn't I? Yeah. So I just wanted to show you something. I totally forgot about two things in the Pandas stuff. So if I have this document and I save it, okay, and I save the date times in Pandas. Oops. Here, look at that. That's one of the problems I get. Date times are their own content type, and sometimes Excel or Excel versions can't read date times. I've run into it a number of times. And it's not a big deal if you're just using data frames and you're keeping everything in Python. But if you're sending this to a client, it is a big deal because they can't read half the stuff, right?
Are those really pound signs, or is it like an integer and it's just because the column's real
Yeah.
short?
The information's still there.
Yeah.
Yep. So it doesn't know how to translate it.
Could you manually go in and change what the data format is in the column?
So here's what I do.
Since the data is already there?
So here's what I do. When I go through and I know that I'm going to be sending this to a client, there's two options. The easiest one that I found is I just use a lambda. Okay, I know I said not to use lambdas earlier, but this is a situation where lambdas are great. So I go through with the entire column. I apply a lambda. I pull out every value of that lambda, and I turn it into a string. You just go boom, string x, boom, boom. And then I know whenever I input or output an Excel file, if I have a date time, I just apply this function. I have it set aside as a helper function utility for me, so that I know that on load, it automatically can go through and do that. That's my preference. I'm sure there's other ways to solve the problem, but I found it's the easiest way for me. Because then when you go in, the date times will be there and they'll all be properly formatted for users to look at. Now, you do have another option, okay? So let's say that you don't have to deal with a client. Let's say that you just need to save it for later. And I have like I don't know, you're talking about gigabytes of data for a client. They give you all this data. And you're gonna do magic with it. So how do you save it and all that stuff? So I prefer Pickle for format. Pickle is a Python serial format. And so the reason I prefer Pickle is because it's binary, so it doesn't care about type conversions. Like sometimes you'll have errors like with date times or other kinds of types in there, and sometimes Excel won't accept them, or if you want to use HDF5 or other kinds of format. So I just use Pickle, which is built into Python, so everybody can use it. That uses Python, right? And so it's really easy because then all you do is to pickle or you repickle. And then you get your pickle file, awesomemeters.pickle, and you can treat it like any other file. And it's just really easy to serialize data.
Have you had issues with HDF5? We've used that at my work, and it's just for.
I have actually, yeah. And I think the date times were the issue that I ran into. And maybe there was who knows? Maybe there was something wrong with the actual date times that I was using. Maybe it wasn't the proper format of the date times. But I have used HDF5 on other programs. We used that in the AI Saturdays course. We used HDF5, and it worked great. Yeah, so I'm not against it by any means. But for a lot of my recent projects, I've been using Pickle. Cool. So that covers. I just wanted to go through some of the most common things that I've been running into in recently with Python, OpenCV, PyTorch, and Pandas. Again, these are just introductory stuff and some of the most common things. We're looking at doing more paid training, probably in the spring into the summer, where we're really going to delve into a lot of these topics and get into some more advanced tools, things that people can use. All right, I think that's about it. Do you have any questions or anything?